So now we see the physical chemical properties of ammonia, the basic nature of ammonia. So we can see an aqueous solution of ammonia is basic in nature. So firstly, perfectly dry ammonia gas or ammonia is in the liquid form is neutral or to dry litmus. That is, ammonia is a very weak base. The basicity due to lone pair of electrons of nitrogen atoms in ammonia. So we know that nitrogen has got the polar covalent compound with in formation of ammonia. So that's it's got one pair of lone pair, and due to this particular thing, this is going to be, because it's got only one pair of lone pairs over there, that is why it is going to be having a very weak base formation. So it is a weak base. So overall, we can say dry ammonia will be almost neutral to dry litmus, but yeah, when it is liquid, when it is ammonia NH3, okay, then it will be neutral to litmus. Liquor ammonia, that is when aqueous solution of ammonia in water is called liquor ammonia or liquor ammonia fortis, that is saturated solution having a specific gravity of 0.88. Preparation wise, by dissolving ammonia gas in water using the funnel arrangement. Yes, the funnel arrangement what we use in HCl, the same we are using in case of ammonia also, whenever you are going to add ammonia to water. So preparation is going to be by funnel arrangement, similar to the preparation of hydrochloric acid from HCl gas. Basic nature of ammonia, the aqueous solution of ammonia NH4OH is alkaline and acts as a weak base. So it undergoes partial dissociation in aqueous solution to give hydroxyl ions in low concentration. So the hydroxyl ion given out by the ammonia is in a lower concentration, hence the strength wise the ammonia are low, we can say weak bases, weak alkali. The alkaline behavior NH4 is due to the presence of hydroxyl ion. So NH3 by H2O will give you NH4OH. NH4OH is nothing but NH4 plus OH minus. So the aqueous solution of ammonia turns red litmus blue and phyllophthalein solution pink. So that is how the aqueous solution of ammonia acts as an alkali. So that's the main part, that it is basic in nature, alkaline solution when it is added with water. So because when it is added to water, it is NH3 plus H2O giving me NH4OH, where NH4OH is nothing but NH4 plus OH minus. So the presence of this OH minus over here makes it basic in nature. So the basic property is because of the dissociation of the formation, ionization over here as OH ions, and here the presence of molecules are there, that's why it's a weak base. Now we talk about the basic, so this was ammonia gas. Now we talk about the ammonia salts. So ammonia is a gaseous form or in a gaseous solution, and aqueous solution H4OH neutralizes acids forming the respective ammonium salt. So yeah, it is going to be ammonia plus acid will give you ammonium salt, or we can say ammonium hydroxide with acid, as acid plus base give you salt plus water. So it will give you ammonium salt plus water. So ammonia being weak base accepts protons, that is hydrogen ion, to form ammonium ion, NH3 plus H plus giving me NH4 plus. It therefore reacts with acid to form ammonium salts. So these are the reaction. We get NH3 plus HCl will give you NH4Cl. NH3 plus H2SO4 will give you NH4 twice SO4. So this is how you are going to have the reaction, or even nitrate also will give you the same thing. NH3 plus HNO3 will give you NH4 twice NH4 NO3. Okay, nitrate will be single, so NH4 NO3. So that is how you are going to get the ammonium chloride, ammonium nitrate and ammonium sulfates, ammonium sulfate and ammonium nitrate available when ammonia reacts with the respective acids. Chloride acid, ammonium chloride, nitric acid, ammonium nitrate, and sulfuric acid gives you sulfate. Same way, if you are going to have, instead of ammonia, if you are going to have NH4OH, then with HCl will give you NH4Cl plus H2O. So this is nothing but base plus acid gives you salt plus water. So that's a simple reaction. Neutralization reaction is going to take place when ammonium hydroxide is going to react with the acids. So all the three same possibilities, nitrates and sulphate also form with the same manner. So NH4 twice SO4 by H2O in case of H2SO4 with NH4OH, and NH4OH plus HNO3 will give you NH4NO3 plus H2O plus H2O. So that will be the process, neutralization reaction, resulting in the formation of ammonium salt and water. Ammonium chloride is an ammonium salt which undergoes thermal dissociation, and that's why it is going to give NH4OH, NH4Cl will give you NH3 plus HCl. So NH3 plus HCl is a reversible reaction giving you NH4Cl. Further, we have aqueous solution of ammonia or excess ammonia pass through aqueous salts solution precipitates hydroxides of metals from the solution of their salts. Ammonium hydroxide reacts with metallic salts solutions like salts of Na and K excluded to give insoluble precipitates of respective metallic hydroxides. The precipitates, which are hydroxides of metallic radicals, vary in color, solubility in excess of NH4OH, and hence ammonium hydroxide is used in qualitative analysis of identifying positive radicals or cations. So this is a very important part of the chapter. Ammonium hydroxide, when it reacts with the salts other than potassium and sodium, because potassium and sodium salts will not give you a colored outcome. Now, for example, if we are taking ferrous, if I take FeSO4 or FeCl3, or I am taking PbSO4 or PbNO3 twice or ZnSO4, in all these cases, when it reacts with ammonium hydroxide, they are going to have a double decomposition reaction taking place, double displacement reaction taking place, and in turn they give you the metallic hydroxides of the metals. So metallic hydroxide, which is formed of iron or lead or copper, they have got a specific color. So first thing is that they have a specific color. Another thing is that these hydroxides are partly, some are which are going to be soluble in excess of NH4OH, and some are which are not going to be soluble even if excess of NH4OH is added to it. So accordingly, it becomes easy for us to identify that what particular cation was present in the salt which is given to us for analysis. So in case of practical analysis, so that is what we are going to learn even in the analytical chemistry chapter. So there same way, if we are given a salt, suppose I am given a salt as ferrous chloride, FeCl3, and I want to know whether it is FeCl3 or not. I want to know whether it is Fe ka chloride or kisi aur ka chloride. So I am just going to add certain quantity of ammonium hydroxide in it, and it will give me, the ferric over here is going to give me reddish brown colored precipitate. The reddish brown colored precipitate is going to indicate that the cation present in the salt was iron, that is ferric. Okay, if it is dirty green color, it will be ferrous. So this gives you a easy method, or which is called as analytical way of finding out what is the positive radical present in the salt, or the cation present in the salt. So that's why we have this particular table over here. So let's go through this one by one, because it's a very important part of the chapter. This is going to be there in 3 chapters. This one, next is analytical chemistry, and lastly is practical chemistry. In all 3 of them, these equations are going to be repeated. So we are learning it over here once and for all, so that everything is going to be confirmed. So first one is when you are taking iron. So we are taking first of all Fe3. That is, I am taking FeSO4, okay, plus NH4OH, okay. So 2 NH4OH is going to give me over here NH4 twice SO4 plus Fe OH thrice. Sorry, twice. This is twice. Okay. Now, the color of this thing. What is the color? This is a precipitate. And what is the color over here? This is ferrous. Ferrous is dirty green. So this is going to be the color dirty green. Okay, dirty green color is there. And if I add some more of NH4OH to it, still it does not dissolve. So in excess, so when I put over here in excess, so in excess NH4OH, it is insoluble. Okay, insoluble in excess of this thing. The next one is FeCl3, that is ferric. Okay, this was ferrous, this is ferric, plus NH4OH will give me the same thing over here, 3, and it will be giving 3NH4Cl plus FeOH thrice as a precipitate, which will be reddish brown. So reddish brown, so that is red. Ferric will be red. Okay, ferric red, ferrous green, and this too will be insoluble in excess of ammonium hydroxide. The next is lead, PbNO3 twice plus 2NH4OH will give me 2NH4NO3 plus PbOH twice. Again, the precipitate will be chalky white, which will be insoluble in excess. Even if I put some more amount of it, it will be insoluble. Insoluble in excess. The next is zinc, ZnSO4 plus 2NH4OH. Give me 2 NH4 twice SO4 plus ZnOH twice precipitate, which will be gelatinous white. Okay, it will be gelatinous white, but this one, when I put some excess of NaOH, it will be soluble. Okay, so what will happen? This, when I add further, so if I use it, so ZnOH twice plus NH4 twice, sorry, NH4OH. Okay, in fact, we will be having this part also. So NH4 twice SO4 plus NH4OH. So these are the three things which I add now. See, these were available to me after this reaction. इसके अंदर मैंने और NH4OH डाला. So I am adding this to this two. I am adding this to this further. So on adding this two further, I get over here as ZnNH3,4SO4. That is nothing but tetraamine zinc sulphate. Okay, tetra 4 is tetraamine zinc sulphate plus 4H2O. So this is what you are going to get as a result of this soluble thing. Then this tetraamine zinc sulphate is a soluble salt form, hence it is going to be soluble. And so you can see both of them are giving you white color precipitate initially. Then how do you identify that which white color is zinc and which white is precipitate is lead? So one which is going to be insoluble is going to be lead on excess, whereas excess में जो soluble है, that will be zinc. So that is how you are going to identify between zinc and lead. The next one is copper sulphate, CuSO4 plus 2NH4OH is going to give me as NH4 twice SO4 plus CuOH twice. Now this CuOH twice is again pale blue in color, so it is a pale blue, and this will be in excess, again soluble. So this will be soluble again. And when I'm adding this to NH4S, so when I take this over here, NH4 twice SO4 plus CuOH twice plus NH4OH, I'm going to get over here as CuNH3,4SO4, that is tetraamine copper sulphate plus 4H2O. So we can see that it is soluble, and this over here will be deep blue. Okay, this is going to give you a deep blue kind of a color when it is going to get mixed up. So it will be a deep blue solution. It will not be a precipitate, it will be a deep blue solution. Okay, so that is what we are having here. Lead salt and zinc salts can be distinguished using excess ammonium hydroxide solution. Since the precipitate of metallic hydroxide formed, lead hydroxide is insoluble and zinc hydroxide is soluble in excess of ammonium hydroxide. So that is one thing. And ammonium hydroxide is first added in small quantity and then in excess in a solution of copper sulphate, forms a pale blue precipitate of copper hydroxide, which dissolves in excess of ammonium hydroxide, forming a soluble complex salt. So that's why we are getting over here soluble complex salt, which is a deep blue or inky blue, which is also called as a inky blue, deep blue or inky blue solution. So that is why CuOH plus NH4 twice SO4 plus NH4OH will give you CuNH3,4SO4, which is nothing but tetraamine copper sulphate, which is deep blue or inky blue solution. We next see is the ammonia reducing action. So the reducing action of ammonia. So ammonia reduces heated metallic oxides to metals. So if you take copper oxide and lead oxide in a chamber, so if you are taking a chamber over here and you have taken the certain amount of CuO or PbO, so if you are taking this lead oxide and Cu oxide, it is going to happen, and when you are passing it through condensed water, so अगर मैंने यहाँ से heat किया इसको and then I pass ammonia through it and then it is allowed to I am going to get, or we can pass it through water, means through a solution over here, condensed water, and then you are going to get in water nitrogen gas. So this of course is not, this experiment is not so important, so I'm not drawing it completely, you can see it from the textbook. So reactants are simple, that copper hydroxide and lead oxide and ammonia, and the product will be copper or lead. So the reaction goes this way: 2NH3 plus PbO, so okay, first is CuO, let's take 3 CuO will give me 3Cu plus 3H2O plus heat, and over here will be 2NH3 plus 3PbO will give me 3Pb plus 3H2O plus heat. So this is the reaction which is going to take place when reaction for metallic oxide, when they react with ammonia, ammonia being a reducing agent, it is going to reduce the metallic oxides to metals. Hence ammonia can be used as a reducing agent, where you can see that oxide of copper and lead got converted into copper and lead metals. So the outcome will be that copper oxide is black in color, whereas the copper what you are going to get will be brown in color. The lead oxide will be buff yellow, whereas the lead you are going to get will be a greyish metal of lead. So the color changes are coming over here. Black color in this case is going to become brown, and this is yellow, buff yellow is going to turn into grey metal. And nitrogen gas is going to be evolved in both the cases also. So yeah, I forgot that, sorry. This will be N2 plus N2 over here. So plus N2 will be formed. So nitrogen gases will be evolved in both the cases. That's an important part of this chapter, of this particular thing. Lastly, again two important reactions wherein ammonia reacts with chlorine and whether or hydrogen chloride, and in one is in excess and one is ammonia in excess, and another the case if chlorine is in excess. So we have got two conditions over here. So first is ammonia, when excess of ammonia is there, so 2NH3 plus we'll directly use the final equation, 8NH3 plus 3Cl2 is going to give me 6NH4Cl plus N2. This is ammonia in excess. And the next one is, if I am taking chlorine in excess, it will be NH3 plus 3Cl2. So this is in excess. It is going to give me 3HCl plus NCl3. Now this is nitrogen trichloride. This is nitrogen trichloride, which is going to be yellow explosive liquid. So this is yellow explosive liquid. So we see here that first of all, when we are taking ammonia in excess and reacting with chlorine or even HCl, in both the cases we are going to get what is NH4Cl. So first thing is chlorine reacting to give me HCl plus N2. So first reaction will be nitrogen ammonia reacting with chlorine to give you ammonium chloride. Ammonia plus chlorine will give you hydrogen chloride plus nitrogen, and then it is going to be further combining into ammonia with HCl giving me NH4Cl. So anyway, you can just take one single reaction directly over here, that ammonia, when it reacts with chlorine and when ammonia is in excess, it gives me ammonium chloride, which is a dense white fumes, and nitrogen gas will be evolved. Whereas ammonia, when it is getting in excess of chlorine, it is going to give me HCl and nitrogen trichloride, which is nothing but the yellow explosive liquid. So the yellow explosive liquid will be formed. Ammonia is thus oxidized by a metallic oxide Cu and CuPbO, and by a gas other than oxygen, that is chlorine. So yeah, ammonia gets oxidized by chlorine. So the preparation of nitrogen from air is not required. Preparing nitrogen unstable nitrogen is not required. So you can skip that part. In fact, it is just for reference. Now we come to the test. So in case of test, first thing is the odor. We know that the pungent odor of ammonia cannot be missed. So yes, characteristic irritating and pungent odor is easily recognizable. And physical nature, it causes an irritation, a burning sensation in the upper part of the nasal chamber and brings tears to the eyes. Physically also we can easily identify ammonia without even testing anything. Litmus solution also, litmus red turns blue, methyl orange turns yellow, and phenolphthalein colorless becomes pink. So neutral litmus purple turns blue in alkaline medium. Yes, of course, if you drink a glass rod dipped in HCl near ammonia, it is going to give me dense white fumes of ammonium chloride. So that is the first test. So test for ammonia and alkaline gas dense white fumes of NH4Cl with HCl is going to be given out. And secondly is about the copper sulphate giving you that deep blue color initially and then excess में डालने की inky blue. That also become a test for ammonium hydroxide. So copper sulphate solution, pale blue precipitate of copper hydroxide is formed. That is CuSO4 plus NH4OH will give you NH4 twice SO4 plus CuO OH twice. That is pale blue precipitate turns deep blue color on passage of excess of ammonium hydroxide, and accordingly we get it as a inky blue solution. And one more thing is Nessler's reagent turns pale. The Nessler's reagent is nothing but potassium mercuric iodide. It is K2Hg I4. This is potassium mercuric iodide. This is Nessler's reagent. So the Nessler's reagent is going to go from colorless to brown. Okay, so when you pass ammonia through Nessler's reagent, it will become brown. On excess of ammonia, it will become brown precipitate. So first it will be pale brown and then it will be dark brown. So this is how you can identify ammonia through the tests over here. Next we see the uses of ammonia. So ammonia is used in sources of hydrogen, then sources for it's a source for hydrogen, it's a source for nitric acid, manufacturing of explosives, ammonium nitrate, dyes and drugs, plastics and resins, baking powder, and that is NHCO3, NaHCO3, washing soda, Na2CO3.NH2O, and artificial silk. As a fertilizer, yes, ammonia is going to have a huge amount of nitrogen in it, and hence it is going to be used as a fertilizer also. So urea contains ammonia. So urea is NH2CONH2. Ammonium sulphate, again a fertilizer. Ammonium nitrate is a fertilizer. Calcium ammonium nitrate and diammonium hydrogen sulphate. All these are different fertilizers. We can also produce good amount of ammonium compounds like ammonium carbonate, which is also called as a smelling salt, which is used to revive a patient who has just fainted. So that is smelling salt, ammonium carbonate. Ammonium chloride, so cleaning metal surfaces dissociated with NH3 and HCl. So that is why ammonium chloride is used. And ammonium sulphate is an important fertilizer application in the production of alum. So that was about ammonia gas. Now liquor ammonia, that is, it's used as a cleaning agent. Now liquor ammonia, it is emulsifier. Emulsifier means it is able to convert the fats of the greases and the oils into easily soluble things. So that's why they are called as emulsifiers. So liquor ammonia emulsifies or dissolves fats and greases, etc. Hence it is used to removing ink and grease stains from clothes. Liquor ammonia is also used for cleaning window panes, porcelain articles, etc. Lastly is liquid ammonia. Now liquid ammonia gas means ammonia gas liquefied at low temperature. Now this is used in refrigerant in ice plants. See, refrigerant means what? AC के अंदर एक gas होता है which is going to absorb the heat and accordingly cool the air. So that is precisely what happens even in a refrigerator. So in very big industries, the refrigerating gas which is going to be used, it could be ammonia, because because of the following properties of ammonia, which makes it a very good refrigerant gas. So what are the properties are? Liquid ammonia is used as refrigerant gas since it is highly volatile. Okay, so it gets converted into gas very fast. So it's highly volatile, has a high latent heat of evaporation. It can absorb a good amount of heat before it gets converted into gas. It can absorb a good amount of heat to change its state from liquid to gas. That's why it has got a high latent heat of evaporation. Easily liquefies under pressure at low temperature. So at the same time, under just a little amount of low temperature and pressure, it is easily getting the gas gets converted into liquid. So the reusability of that particular gas for absorbing the heat from the device also becomes faster. See, that is what exactly is required. AC में होता क्या है कि there are the gas which is there in the compressor pump is there. Gas is moving around, and when it is moving around, the air is passing through there. So यहाँ पे tubes में से gas जा रहा है और air यहाँ से जा रहा है. तो tubes में जो gas जा रहा है वो air में से heat absorb कर लेता है, and then on absorbing the heat, that gas which is passing through gets heated up. Okay, so that when it gets heated up, it is going back into the compressor where it is getting converted into liquid again. So वो liquid फिर से पास होगा, तो फिर से वो heat absorb करने लगेगा, फिर से उसको condense करेंगे और फिर से उसमें भेजेंगे. ऐसे करके वो rotation चलते रहता है. So that liquid, so it is very important that that particular gas which we are using as the refrigerant gas should be such that it gets liquefied also very easily. So एक तो heat easily absorb करना चाहिए from the air, क्योंकि air is just passing through, उसमें से heat absorb करना है, and उसके बाद में heat absorb करने के बाद में वो cool down भी जल्दी easily होना चाहिए. So that's why we say that it easily liquefies under low temperature. If therefore liquid ammonia is evaporated, a relatively large amount of heat is absorbed from the surrounding and the water is converted into ice. So that is what they say, that when a liquid ammonia is converted into gas, so at that time when the liquid ammonia is converted into gas, it can absorb a huge amount of heat from the atmosphere around it. Hence it is cooling the thing faster. So heat of evaporated ammonia is 5.6 joule, that is calorie at minus 33 degrees Celsius. And that is why it is also one very important thing that ammonia, like another refrigerant gases, the other refrigerant gases are chlorofluorocarbon, CFC. So since chlorofluorocarbons are very bad because they are causing global warming and ozone layer depletion, that's the reason it is better that we use ammonia as the refrigerant gas rather than using the chlorofluorocarbons. So suitability, so we can see that chlorofluorocarbon causes ozone depletion. So chlorofluorocarbons are chemical which like liquefied ammonia gas has used as refrigerant gases. Unlike liquid ammonia, chlorofluorocarbons enter the atmosphere due to their excessive use as coolant in refrigeration and AC plants, aerosol sprays and cleansing agent. They cause ozone depletion in the atmosphere, and chlorofluorocarbons are decomposed by UV rays to give free chloride radicals. So that accordingly, this chloride radical break the ozone layer to give you ozone depletion. So that's why ozone depletion takes place due to chlorofluorocarbons, due to formation of chlorine radical, that is chlorine radical, free radical being formed. There's the ozone layer which prevents harmful UV radiations from reaching the earth and endanger humans, and plant life gets depleted. So suitable alternative for chlorofluorobars which are non-ozone depleting. So they include hydrochlorofluorocarbons, which acts as a substitute of fluorofluorocarbons and can be used. So yes, nowadays you don't find any of the refrigerators or the air conditioners using CFC. They, in fact, you will always find a sticker on it saying that non-CFC or CFC free करके वो stickers आएंगे उसमें, because they don't use CFC, they use HCFC, which are hydrochlorofluorocarbons, which will not allow the free radicals of chlorine to get out, and accordingly they will be not depleting the ozone layer. So yeah, so this was the chapter ammonia. So we complete the chapter ammonia over here. So the next time we will start with a new chapter, and that will be nitric acid. So that was ammonia for you.